In our final section of Chapter 8, we're bringing together two ideas that we're already familiar with and just showing how they can agree with each other, how they can kind of back each other up. When the null hypothesis, so if you go through, you do your hypothesis testing, all 5 steps, whether it's traditional or p-value, doesn't matter. So when the null hypothesis is rejected, so you do your hypothesis test, all 5 steps, traditional or p-value. When the null hypothesis is rejected, if we compute a confidence interval, and that's what we just did last chapter, if we compute a confidence interval at the same significance level, that interval will not contain the value of the, and really this shouldn't be mean, it should be parameter. Because it could be a mean, it could be a proportion, it could be a variance, it could be a standard deviation. So we're going to show today, we're going to have some information, we'll run a full-out hypothesis test, all 5 steps, and then we'll find a confidence interval with the same significance level and see if they agree. So if we decide to reject our null hypothesis in our hypothesis testing, our confidence interval will not contain our hypothesized value. Now then the flip of that, when the null hypothesis is not rejected, if you compute your confidence interval, same significance level, it will contain the value of the mean. Or it shouldn't be mean, sorry, let's scratch that, parameter. Because it could be a mean, it could be a proportion, it could be a variance, it could be a standard deviation. So we don't have to relearn any new things with hypothesis testing. We're not relearning anything new with confidence intervals. We're just showing how the two can back each other up, how they can agree with each other. So what I would like you to do, there is an example, and if you write a little bit larger, if you don't have very small handwriting, you might want to do your work on the back side of your sheet, just a suggestion. What I would like you to do is read through the given information and go ahead and do all 5 steps of the hypothesis test. Don't worry about the part yet that says find the 90% confidence interval. So stop at this part right here. So go ahead and do the all out, decide what parameter you're actually testing, and then go ahead and do the 5 steps. Is it traditional? Is it p-value? Make your decisions. I will start gradually putting the steps up here. After a couple minutes, I'll start putting some stuff up there for you. Again, I'm going to just start gradually writing steps up here. So use mine to check. Use mine to check. I'm not going to put any extra work up here of how I got critical values or how I'm going to get test values. So use mine to check. If something isn't matching, please ask me so I can help you figure it out on yours. So now if we want to use a confidence interval just as a second way to show that our conclusion is correct, that we should reject the null hypothesis. So what we need to do when we do the confidence interval, now you guys are often told in the question what percent to use for the confidence interval. So this one says 90%. How do I know what to use? So if you had to do this someday on your own as the researcher, if your alpha is at 0.1, your confidence level for your confidence interval should be at 90%. If your alpha is at 0.05, your confidence level would be 95%. I'll just jot a few of those down just so you see how they match. I'll do the three most commonly used ones. So this is the one that's going to work for us for today. So that's the one that's going to work for us. Those two need to match. Your significance level and your confidence level, they need to match up. So now it's your choice. I know some of you, this is from chapter 7, some of you like to use the formulas, some of you like to grab the calculator and find the interval. It absolutely doesn't matter. The formula piece, I'll jot that down here. And then I will refresh where to find these things on the calculator. I know it's been just a little bit since we've done those. And now here's the nice thing. I know some of you, I write z sub alpha over 2 up there. And I know some of you it makes you cringe, like, oh, that z sub alpha over 2, I thought maybe I got rid of that. But here's the nice thing though, if you have a two-tailed test, your z sub alpha over 2, guys, is already found. It's just your critical values. Remember, finding those critical values was the same process we had to use with our z sub alpha over 2. You know the area, you have to find the z value that associates with that area. So let's see, our x bar, our sample mean was 48. Z sub alpha over 2, I'll go with 1.65. Doesn't matter which one you use. Either one will get us what we need. Our population standard deviation was found to be 8. Sample size, we did 10 trips. And then I know some of us really like those confidence intervals because the left side and right side, they were the same thing except one was plus and one was minus. So we do a little computation. And just kind of go with me on this. Again, I'm going to try to make this as short and sweet as possible for you. So here's the idea. Hypothesis test, the 5 steps we did at this point, we should be comfortable with those. We're wrapping up our unit on those. We should be pretty comfortable. Confidence intervals, we just did that last unit. Overall, fantastic unit for everybody. So far you're thinking, okay, Miss Golly, so what's new? So far, nothing. Here's the new idea, though, is we're trying to show how the confidence interval backs up or agrees with what we did in our hypothesis test. So here's what we started with today. So we rejected, our hypothesis test said to reject. So what does that mean? That means that our confidence interval should not contain the 42 that we hypothesized our mean to be. So we rejected the null. So the confidence interval does not contain the hypothesized mean of 42. So it agrees with the hypothesis test result to reject the null hypothesis. It's got a mind of its own, guys. Sorry, it skipped way ahead. There we go. So again, and I know we stated this on our very first piece today, if you reject the null hypothesis, the value in your hypotheses, whether it's a mean, a proportion, standard deviation, variance, whatever it happens to be, if you reject the null hypothesis, the value in that null hypothesis should not be in your confidence interval. If you reject the null hypothesis, the value in your null hypothesis should not be in your confidence interval. Now, if we happen to not reject the null hypothesis, then the value in your null hypothesis should be in that interval. So if your hypothesis test shows to reject the null, the value in your null should not be in the confidence interval. Should not be in there. If you don't reject the null, the value in the null should be in your confidence interval. That's just giving you an extra little backup. Here's what we found in our hypothesis test. Our confidence interval agrees. But again, the confidence interval and hypothesis test, those significance levels have to match. Otherwise, you can't use one to show that, yep, it's backing it up, that they agree with each other. They have to be at the same level. So really, not a lot new today. Not a lot new. So the hypothesis test, 5 steps, not new. Confidence intervals, not new. Just how we're using one to back up the other, that's the new idea today.